Okay, let's do another test for series convergent at 11.6. And this test we're going to do today is the root test. So, as always, we're going to start with a series. N equals 1, doesn't have to be 1, but I'm just always picking one. So I got a series. Now, here's what the root test is. Now, you don't use the root test that much. The ratio test, what we did the last time, is the one I use most often. But what's nice about the root test, if you know the ratio test, there's not a whole lot you need to know about the root test. And usually problems that need the root test done to them are just screaming at you, do the root test. So root test is pretty easy. So what you do, you got a series. You take the inside part, you take the sequence part, and you look at the limit, n goes to infinity, of the nth root of a to the n. Or another way to look at it, you can say you take the limit as n goes to infinity of a n to the 1 over n power. Okay, now, so it's written in books this way, so I'll go with that one. So again, you take a series, and one more thing, absolute value inside. So you can take a series that has inside parts that are positive, negative, you don't care what they are, and you look at the sequence of the nth root of the absolute value of the inside parts. And it's exactly like the ratio test. If this guy equals L, and if L is less than 1, it converges absolutely. If L equals 1, you have no idea, you just wasted your time. And if L is bigger than 1 or infinity, the series diverges. So just like the root test, once you get your limit, the limit's less than 1, this series converges absolutely. If it's equal to 1, the test didn't tell you anything. And if it's bigger than 1 or infinity, it says that this series diverges. I'm going to do a couple examples. Again, I said these guys kind of scream at you, you need to do the root test on them. Okay, so we got the summation n equals 1 to infinity, and I got 2n plus 3 over 3n plus 2. And then that's raised to the nth power. Okay, you can tell this problem came from the textbook, because look at it. I really wish that n wasn't there. But if I do the root test, I'm going to raise this to the 1 over n power, and it's going to kill that n. So this is just screaming, use the root test on it. So I'm going to take the limit as n goes to infinity of an to the 1 over n power and see what happens. So what's this going to be? That's going to be the limit. N goes to infinity of 2n plus 3 over 3n plus 2 to the nth power. And then I'm going to do absolute value of this. Don't forget that. In this case, it doesn't really matter. And then I'm going to raise this to the 1 over n power. Now that n, 1 over n is going to kill this n, and this is just going to be the limit. N goes to infinity. These are all positive numbers as long as, n's positive. And so those are going to cancel. I don't need the absolute value bars since it's positive. I'm just going to n plus 3, 2n plus 3 over 3n plus 2. I'd multiply top and bottom by 1 over n. And this is going to be the limit. N goes to infinity. When I do that, that's going to turn into a 2, and that's going to be a 3 over n. We get a 2 plus 3 over n. And this is going to be I don't know where the half came from. That's an n. If I do that, I'm going to get a 3, and that's going to be plus 2 over n. Okay, now as n goes to infinity, that guy's going to go 0, that guy's going to go 0, so the whole thing's going to end up being 2/3. Okay, if it's 2/3, what are you going to do? Remember the stuff we did on the ratio test. It's the same here. If you do this and your limit of the sequence part, when you do the square root of it, not square root, the nth root, if it goes to a number, if that number is less than 1, the original thing converged absolutely, since 2/3 is less than 1. Okay. Do one more example. So I got the series n equals 1 to infinity, and I got a minus 2 to the n, and it's over n plus 1, and it's raised to the 5. I'm going to try to be careful on 5. That's a 5 n power. Okay, where's this guy going to go? I don't know, but I see it's raised to an n power. So I'm thinking the root test. It's got this negative in it. Is that going to cause problems? No, because I'm going to drop absolute values on it. So I'm going to look at the limit. N goes to infinity of the nth root. I'm going to write it the other way. The nth root of the absolute value of a minus 2n, n plus 1 to the 5n power. Now what's going to happen here? I got power to power. What do you do power to power? You multiply. So it's going to give you the limit. N goes to infinity. Power to power is going to give you a 5. So it's going to be absolute value of a minus 2n over n plus 1 to the 5th power. Because the n's canceled when I multiply those two. Absolute value is going to kill that negative, and everything else is positive, so it's going to give you the limit. N goes to infinity of 2n over n plus 1 to the 5th power. Okay, since 5 is a continuous function, I can bring the limit on the inside, so it's going to equal the limit. N goes to infinity of 2n n plus 1 to the 5th, and I was able to do that because 5 is a continuous function. Now what's the limit of this guy? I'll do it real quick. That's multiply top by 1 over n. And so you're going to get the limit. N goes to infinity. And that's going to be a 2 on top. And on bottom, I'm going to have, that's going to be a 1. And that's going to be plus 1 over n. And this is to the 5th power. Okay, you can see that. So it's 1 over n. Okay, so as n goes to infinity, that's going to go to 0. This is going to be 2 to the 5th power, which equals 32. Okay, so I took the insides of this guy, I took the nth root of the absolute value of this guy, and I went to 32. What do you got? They got to be less than 1 good, equal to 1, you wasted your time. Bigger than 1 means it diverges. So this guy, 32 is definitely bigger than 1, so this guy diverges by the root test. Okay, so root test, pretty easy. If you know the ratio test, there's not a whole lot more to remember about the root test. All right, that's it on the root test.